When we look at KSP problems, sometimes we're asked to decide whether or not a precipitate is going to form when two solutions are mixed together. So if we look at this particular problem, we're asked if we were to mix 25 milliliters of 0.0020 molar potassium chromate and 75.0 milliliters of 0.000125 molar lead nitrate, will a precipitate form? So the first thing we'll do is we'll kind of review writing our equations, and then we'll go through our KSP problem. So potassium chromate is K2CrO4, and it's aqueous because it's in solution. And lead nitrate is PbNO3, again aqueous. It's a double displacement reaction, so we're going to produce potassium nitrate and lead chromate. We know that any compound that has potassium or nitrate in it's soluble, so this is not going to be a precipitate. But if we have enough ions in solution, the lead chromate will precipitate. So we want to figure out what the lead ion concentration is in the solution after we mix it together, what the chromate ion concentration is after we mix the solution together, figure out what the product of those concentrations would be, and then compare it to the KSP value. So let's start with the lead ion first. It tells us that we have 75 milliliters of 0.000125 molar lead nitrate. Okay, and we're going to mix it with 25 milliliters of the other solution. That means that we're diluting the lead nitrate, and we want to calculate what the new molarity is going to be. So we'll take our M1V1 equals M2V2 equation. So the concentration of our lead nitrate, 0.000125 molar. The original volume is 75 milliliters. What will the molarity be when our volume is 75 plus 25 milliliters? So we're going to get a concentration of lead nitrate of 9.38 times 10 to the minus 5. And for every 1 mole of lead nitrate, we're going to have 1 mole of lead ions. So that's also going to be the concentration of lead ions in our new solution. We're going to do the same thing for our chromate. Again, we're going to take the potassium chromate solution and mix it with the lead nitrate solution, so it's a precipitate or a dilution problem. So M1V1 equals M2V2. So for the potassium chromate, the original concentration is 0.0020 molar, and the volume originally was 25 milliliters. What will the new molarity be when we mix the two solutions together? So 75 plus 25 milliliters. So the new concentration of our potassium chromate is going to be 5.0 times 10 to the minus 4. And since it's a 1-to-1 ratio of potassium chromate to chromate ions, this is the concentration of our chromate ion. Now we're going to write a KSP expression. We've got the concentration of lead ions times the concentration of our chromate ions. And we'll plug in the values that we have in the solution. So we've got 9.38 times 10 to the minus 5 times 5.0 times 10 to the minus 4, which is going to give us a value of 4.69 times 10 to the minus 8. Now what we want to do is we're going to compare this value with this value. This is the maximum product of lead ions and chromate ions that can remain in solution. Anything higher than that is going to start to form a precipitate. So if we look at the value that we just calculated, 4.69 times 10 to the minus 8 is greater than 2.0 times 10 to the minus 16. So yes, we're going to form a precipitate.